Okay, this is going to be a sort of just me doing some example problems with U-substitution with some sort of new things or maybe perhaps some insight into my thought process on U-substitution. And these questions on the left, these four here, these are multiple choice questions would be multiple choice questions. I just took out the multiple choice because I want you to just be able to do it. This one is a particularly tricky one, this first one here. So I'll work through it all together. I really take my time with this one. But for this one, I'm looking at 1 over the square root of 9 minus x squared, the integral of that, the antiderivative of that. And this doesn't look exactly like anything we've seen before, but it looks similar to my inverse sine antiderivative. So the question is, what can I do to this to make it look more like that? Okay, well, we're missing, we want this 9 to become a 1. How do we do that? How do we get that 9 to become a 1? So how do I make this 9 a 1? Very unintuitive thing to do. But we are going to factor out a 9 out of this thing here. And if you're wondering, how do I factor out a 9? This is something we do in math, but you would never do this when you're doing like algebra or even up to now, you've probably never done this. But there's always a factor that you can pull out. And so what I mean by factor out a 9 is, well, if I pull out a 9 out of this one here, I'm left with 1. If I were to pull out a 9, if I were to divide this by 9, well, what am I left with? I'm actually just left with x squared divided by 9. This is a really unintuitive step, but this is something you can do, because if I distribute this back in, it'll still be the same. 9 times 1 is 9. 9 times x squared divided by 9 is x squared. So we're still mathematically the same. And what can we do now? Well, using sort of our square root properties, what is the square root of 9? Well, that's 3. So I'm going to get the integral of 1 over 3 square root of 1 minus. And then this, I can rearrange this a little bit, and sort of why I'm doing this hopefully becomes clear in a second, but I want to try to simplify this and make it look cleaner. If I make this, take this squared and sort of distribute it to the whole thing, what is the square root of 9 is 3, so I get x over 3 squared dx. And now, this is looking almost exactly like my arcsine, because I have 1 over the square root of 1 minus something squared. So the question is, how do we sort of work with this? Well, let's just u sub this. U equals x over 3. And du equals 1/3 dx. And now, while I have a 1/3 right there and I have my dx, I can rewrite this with a u substitution of 1 over the square root of 1 minus u squared du. And now we've gotten it to look exactly like our arcsine inverse. So this is going to be arcsine of u plus c. Because remember, when we're doing an indefinite integral, we always need to have our plus c. And finally, I'm just going to rewrite this u in terms of x. It was x over 3, so we have arcsine of x over 3 plus c. And boom, this is our antiderivative of, this is our antiderivative of that. So this one was really unintuitive, which is why I went through really slowly to do it all together. But I think these next two are are more intuitive. So I want you to pause the video and I want you to try and do, well, I'll do this one. And then when I come back, I'll have this one worked out and we can see if we have the same thing together. Okay, coming back, the work for this one was a little messy. And there were probably some parts that we got confused on or struggled on. But we should have found that this function right here is our u, take the derivative of that with no problem. The part we had to do here to make it a little easier is we had to factor, because we want this to turn into x squared plus x. So if I just factor out a 4, we get x cubed plus x. And then our du over 4 equals this times dx, so we have this, and this turns into du over 4. So we get 1 over 4 times u to the 1/2 du. And I found that my bounds of integration, by substituting in 0 and 1 to this function right here, we got 9 and 12. And then when I integrate this is just our power rule, so I add 1. 1 plus 1/2 is 3 over 2, and divide by 3 over 2. And then that, when you simplify that, turns into 1 over 6. And then we're just using our fundamental theorem of calculus, so 1/6 times 12, our upper bound to the 3/2, minus 1/6 times 9, our lower bound to the 3/2. This is the part where you probably struggled with, or you might have put it in a calculator. You do need to know how to do this by hand. I didn't show all the steps for this. If you have trouble with this, please ask me in class and I will go over it slower. You need to be able to get to this without a calculator. That is expected. So if you have any issues, please let me know and I'll spend some time going over this more slowly. Okay, and this is our this is our area under the curve. That's how I should say this. For a definite integral, it's our area under the curve. Okay, third one, I'll let you try and do it on your own, and then we'll come back together, and when I come back, I'll have it all, and I'll talk through it sort of quickly. Okay, this one was pretty straightforward. Our denominator, because I noticed that this is an x cubed, if I take the derivative of x cubed, it's going to get me to x squared. So this is what I u-subbed. And when I take the derivative of that, it's similar to what we just had to do. We end up with 9x squared plus 12x plus 3 dx, and we need to factor out a 3. And we want to make this into something we can substitute, so divide by 3, and we have the 3x squared plus 4x plus 1, and the dx, that becomes du over 3, so I had 1/3 times 1 over u du. The integral, the antiderivative of 1 over u is ln of the absolute value of u, so I got that, and then I just substitute the x back in. This one was pretty straightforward. Last one, this one is very similar to the first one we did, so I want you to try this one on your own, and then we'll come back. And when I come back, I'll have this one and talk through it kind of quickly. Okay, so this one, very similar to our first one. This looks similar to my my arctangent antiderivative, so I just sort of flipped it around because if I remember correctly, let me double check that I didn't do extra work. Yeah, our arctan looks like 1 plus x squared, 1 over 1 plus x squared, so the first thing I did is I just rewrote this to be 4 plus x squared instead of x squared plus 4. And then I factored out a 4, so we end up with 1 over 4 times 1 plus x squared over 4 dx. And then I simplified my x squared over 4 because I want this to just be something squared. So I got 1 over 4 times 1 plus x over 2 squared. Now that I have 1 over 1 plus something squared, I did my u sub, u equals x over 2, du equals 1/2 dx. Multiply both sides by 2, 2 du equals dx, and I come over here. And I went ahead, 1 over 4 times 2 is 1/2, that's where this came from, times 1 over 1 plus u squared times du. This is our arctan antiderivative. So we end up with 1/2 times arctan of u plus c, and then I just substituted in my x over 2 for u, and here's our full antiderivative, and boom. So that was those three. Now I'm going to come over and I will give you a little bit of time or I'll say to pause before each one, but I am going to walk through these very meticulously for the FRQ part. So if you get stuck, I'm going to spend a lot of time talking through every piece I have, but go ahead and try and do, let me zoom out a little bit so you can see it all. Part A, yeah, this is all you need. Part A on your own, and then when you come back, I'll walk us through it. Okay, so our first part here. Is there a value of x for -3 is less than or equal to x is less than or equal to such that g of x equals 0? Justify your answer. I'm not going to go through all this stuff here. We can come back to that later. But I do want to take out is, what is g of x? Well, g of x is this thing right here. I'm going to write that down. G of x equals -6 plus our integral from -3 to x of f of t dt. And it's just asking, is there a value for x from -3 to such that g of x equals 0? Well, what theorem are we going to use here? What theorem guarantees that our original function equals some value? That is our intermediate value theorem. Okay. And what do we need for our intermediate value theorem? Hold on one second. I want to have my notes up. I'm making sure to get everything right. Okay. So what do we need for the intermediate value theorem? We need g to be continuous. So note g is continuous. And why is g continuous? This part is going to be new, so I'm going to take my time with it. G is continuous because our function f is continuous. So that's the first piece. F is continuous. And we need that because part of our g of x is f. So f is continuous. And this g function is defined by an integral. So that means it's an antiderivative. So g is continuous because f is continuous. And let me be more specific. F is continuous on -7 to 9. Because if we look here, well, f is continuous everywhere. It just tells us that f is continuous everywhere. And because g is our antiderivative, it's going to be continuous on this -3 to 2. And since, and I'm probably going to pause in a second and explain that a little bit in more depth. But let me just write it really quick and then I'll come back. And since G is an antiderivative of f, it is continuous on -3 to 2. Okay, so let me write all this and then I'm going to come back, maybe get it to show up. And then I'll explain this a little bit better. Okay, I was just missing one little piece that I'm just going to add to us now. So what does this mean? So earlier we talked about and we said that something being integrable does not mean it is continuous. But here's another sort of relationship that's a key note to take away. If something is, if f is continuous, so if a function is continuous, that means that the antiderivative is also continuous. So that's the connection we kind of need. I don't like how I wrote this if f. It looks kind of like if and only if. So if f is continuous, its antiderivative is continuous. So since we're noticing that G is an antiderivative of f, because if we take G prime, I'll even write that out here, it's probably going to be helpful later. If we take the derivative of this, it gives us G prime of x equals, what is the derivative of this? Well, this is our second fundamental theorem. This is just going to be f of x. So G prime of x equals f of x. This is an antiderivative. G prime is the antiderivative of f. So since f is continuous, G prime is G is also going to be continuous. The antiderivative is also continuous. Okay. So we've said that G is continuous. Now we just need to find G of -3 and G of 2. And I'm going to have to come over to the side here because I'm running out of space. So G of -3 equals -6 plus the integral from -3 to -3 of f of t dt. And G of, what's our other one, 2? Yeah, 2. 2 equals -6 plus the integral from -3 to 2 of f of t dt. And well, how do we get this? Well, remember our integral is our area under our curve. My button is not pressing when I press it. Okay, there. Okay. So we want the integral from -3 to -3. Well, that's from here to here. Obviously, this area under the curve is going to be 0. We're not moving anywhere, so this one just equals -6. And then from -3 to 2, that's from -3 to 2. This is part C. It tells us here the regions A, B, C, D, E have areas 5, 2, 16, 5, and 6 respectively. So A, B, C, 1, 2, 3, 1, 2, 3. C is an area of 16. So -6 plus 16 is +10. And so now, we can come back over here and I'm going to have to write kind of small. Hopefully I can fit it. Since 0 is between, actually I'm going to write it sort of more mathy way, since g g of -3 is less than 0 is less than g of 2. There is a value of x such that f of x equals 0 by IVT. Okay. And where are our points in this question? This question is worth 2 points. 1 point was for this work right here. So all of this and all of this. That was 1 point. And then our justification using intermediate value theorem, so saying that it's continuous in y, and then this part here. So all of this here was worth the 2nd point in this question. Okay, part B, find the absolute minimum value of g and the absolute maximum value of g on the interval -7 to 9. Justify your answer. I'll scroll it like this so you can look at it really quick. And when I come back, we'll go through this one together again. This question is worth 4 points, and coming back, one of the points we actually would have already earned for this observation up here using our 2nd fundamental theorem, but I'm just going to rewrite it down here. If we sort of point out that g prime of x equals f of x, this is a whole point right here. This is one of our points for this question. And so now we need to think about minimums and maximums. Well, minimums happen and we're going from -7 to 9. Okay, so minimums and maximums happen where our derivative is 0 or undefined, and we're switching signs. So where is g prime of x equal to 0? Well, where does f of x equal 0? That's going to be at -7, -5, -3, 2, 6, and 9. Hold on 1 second. Okay, so another point we can get here is we could just make an observation that our possible ones, our critical points, are x equals -5, -3, 2, 6, 2, and 6. This would be worth another point right here. Just pointing out our some of our possible candidates. And the next thing we need to find the absolute minimum, and our next 2 points are finding the absolute maximum, min and max, that's 1 point, and then justifying that. And we're actually going to do this backwards. We're going to do the justification first, and then we're going to come back to our answer. Because our justification for here, we don't actually need words, we just need to consider our x value and our g of x value. This is going to be our justification, this sort of table right here. And we don't need to only consider our critical points. We also need to consider our endpoints. So we're looking at -7, -5, -3, 2, and 9. Take a moment and think, why did I not include 6 on this list? Well, is it possible for 6 to be a min or max? What are our conditions for a min or max? It's that it equals 0 and we're doing what? We're changing signs. Are we changing signs here? No. So this 6, it's a critical point, but it's not actually a spot we should consider. And now we're just going to find these values. So -6 plus the integral from -3 to -7 of f of t dt. I'm actually going to give myself a little more space. I didn't give myself enough space. -7, -5, -3, 2, and 9. Okay. And then -5 is -6 plus the integral from -3 to -5 of f of t dt. -6 plus the integral from -3 to -3 of f of t dt. -6 plus the integral from -3 to 2 of f of t dt. And a -6 plus the integral from -3 to 9 of f of t dt. Okay, I want you to go ahead and try and figure these out on your own. I will talk through it slowly, but some of them we already figured. So like this -3 and 2 we did up here, so I'll go ahead and fill those in because we already did the work for that. And then when I come back, we'll go through all the other 3 together. Okay, so looking at this one here, this one is tricky. And I'm going to go through this one carefully. Because if we look, our lower bound is bigger than our higher bound. -3 is greater than -7. So we need to use an integral rule to rewrite this. This is actually going to be the same as -6 plus the integral from -7, or I'm sorry, not plus. I emphasize the plus, but it should be minus because when we switch the bounds, we're making our integral negative. So this is actually the same as this integral here. -6 minus the integral from -7 to -3 of f of t. Well, let's look. -7 to -3, well, that's a, which is 5, and b, which is 2, but this is below the x-axis, so it's going to be negative, so 5 minus 2 is 3. -6 minus 3 is going to be -9. So there's 1. Okay. And then from -3 to -5, again, we need to rewrite it. So we get -6 minus the integral from -5 to -3 of f of t dt. And we're looking from -3 to 5. That's going to be this 16. And then this one right here is 5, but again, it's below the x-axis, so it's -16 minus 5 is 11. So we end up with -6 minus 11. Did I do something wrong here? Oh, I'm sorry. I'm looking at the wrong. We're going from -5 to -5 to -3. That's just this b part right here. I don't know what I'm doing. This is just 2. Sorry, -2. I made a mistake. Hopefully y'all caught that and were yelling at me. It's -6 minus -2, which equals -4. This is why I like having my notes in front of me, because if I make mistakes, I can also catch it before I post these videos. Okay, we already did -3, we already did 2, now let's look at 9. We're going from -3 to 9, we don't need to rewrite our integral. Our lower bound is less than our upper bound. So -3 all the way to 9, so that's going to be 16 minus 5, 11, minus 6, 5. So this is going to be -6 plus 5. And just in case, because a thought that's been going through my head is like, I would always ask a lot when people did video notes is like, where did he get that from? Well, remember our areas for these are right here. So I was just looking at the areas here. A is 5, B is 2, C is 16, D is 5, E is 6. So in case somewhere along the way you got lost about where I was getting those areas from, I was just getting them from the question. Okay. And so now this is already our sort of justification. But let's just get our answer and then we'll be done with this. So which of these outputs, which of these g of x values is our, let's start with our minimum because it starts with our minimum there, smallest number? Well, our smallest is -9. So g of -7 equals -9 is, I was going to say r, but I don't want to say r, is the absolute minimum. And notice I'm abbreviating. Anytime you can abbreviate, abbreviate. And then what is our biggest number here? Well, our biggest number is 10. So g of 2 equals 10 is the absolute max. And this was worth 1 point, and all this work over here, this is our justification, this is another point. Which I'm not going to highlight because I would be highlighting a lot. All right, part C. This one is worth 3 points. Between these two specific parts here. So this part 1 is worth 1 point. And part 2 is going to be worth 2 points. So let's start with part 1. This is going to be worth 1 point. So this one, very simple. What is the antiderivative of 2x plus 16? Well, the antiderivative of 2x plus 16 dx is just going to be, or I'll pause, I'll let you try and do these two on your own, and then we'll come back. Okay, so now that you've tried it on your own, this is just our power rule, this 2x, so it's just going to become x squared, and then this is a constant, so it becomes plus 16x plus c. And this answer right here is worth 1 point. If you miss any single part of this, you do not get the point. And what I really want to focus on is this plus c. If you do not put plus c, you do not get that point. So I really want to harp on when we have an indefinite integral, we need a plus c. Okay, and now our second one, this second one, we want to find the value of negative 7 to negative 5 of f of 2x plus 16 dx. Well, we don't know this, but what is this sort of, this one here, I didn't say this super much with substitution, but I'll say it now because it's coming up. What is the derivative of this inside? It's just 2. It's just a constant. So I can U-sub, and that won't introduce any new variables or new functions that are going to mess stuff up. So let's just U-sub this. So U equals 2x plus 16. Then du equals 2 dx. du over 2 equals dx. So this is in setting up our U-sub, and now let's also think about our bounds of integration. So 2 times negative 7 plus 16 and 2 times negative 5 plus 16. 2 times negative 7 is negative 14 plus 16 is 2. 2 times negative 5 is negative 10 plus 16 is 6. So if we put this all in, this would give us the integral from 2 to 6 of f of u du. And now, can we integrate this? Well, the integral, remember, the integral is just our area under our curve. So if we're looking from 2 to 6, well, 2 to 6, this is d, 1, 2, 3, 4, 1, 2, 3, 4. That had an area of 5. And it's underneath the x-axis, so it's negative 5. So this equals, oh, I'm sorry, I missed something. You should have been yelling at me, hopefully. I missed this 1 over 2. I'm just going to put it as a coefficient in the front of our integral. So we get 1/2. And then what did I say? It's 1/2 times negative 5, which negative 5 over 2, or actually, I'm not even going to simplify. I'm just going to leave it like that. And this is going to be our final answer. This is a safe stop. I'm just leaving it right like that. So, where are our points for this? Well, our points, I said there were 2 points for this question. This is worth 1 point right here. All right, for part 2, there was 2 points. This is worth 1 point. And that, when I say that, it includes, it's the U substitution and changing the bounds of integration. And then our other point here was the actual answer that we got. So recognizing that this is the area under the curve from 2 to 6 and 1/2 times that area. And that's your 2 points there. This was your 3rd point for that question. Okay, and that covers my, and I went in depth over that FRQ, our U substitution practice. Thank you for watching.